In electronics, a Dekatron is a gas-filled decade-counting tube. Decatrons were used in computers, calculators and other counting-related products during the 1950s and 1960s. Dekatron, now a generic trademark, was the brand name used by the British Ericsson Telephones Limited, of Beeston, Nottingham. The Dekatron was useful for computing, calculating and frequency dividing purposes because one complete revolution of the neon dot in a Dekatron means 10 pulses on the guide electrode, and a signal can be derived from one of the 10 cathodes in a Dekatron to send a pulse, possibly for another counting stage. Decatrons usually have the maximum input frequency in the high kilohertz range. 100 kHz is fast, 1 MHz is around the maximum possible. These frequencies are obtained in hydrogen-filled fast Decatrons. Decatrons filled with inert gas are inherently more stable and have a longer life, but their counting frequency is limited to 10 kHz. Internal designs vary by the model and manufacturer, but generally a Dekatron has 10 cathodes and 1 or 2 guide electrodes plus a common anode. The cathodes are arranged in a circle with a guide electrode between each cathode. When the guide electrode is pulsed properly, the neon gas will activate near the guide pins, then jump to the next cathode. Pulsing the guide electrodes repeatedly will cause the neon dot to move from cathode to cathode. Hydrogen Decatrons require high voltages ranging from 400 to 600 volts on the anode for proper operation. Decatrons with inert gas usually require 350 volts. When a Dekatron is first powered up, a glowing dot appears at a random cathode. The tube must then be reset to zero state by driving a negative pulse into the designated starting cathode. The color of the dot depends on the type of gas that is in the tube. Neon-filled tubes display a red-orange dot, argon-filled tubes display a purple dot. Counter Decatrons have only one carry-borrow cathode wired to its own socket pin for multi-stage cascading and the remaining 9 cathodes tied together to another pin. Therefore they don't need bases with more than 9 pins. Counter selector Decatrons have each cathode wired to its own pin, therefore their bases have at least 13 pins. Selectors allow for monitoring the status of each cathode or to divide by n with the proper reset circuitry. This kind of versatility made such Decatrons useful for numerical division in early calculators. Decatrons come in various physical sizes, ranging from smaller than a 7-pin miniature vacuum tube to as large as an octal base tube. While most Decatrons are decimal counters, models were also made to count in base 5 and base 12 for specific applications. The Decatron fell out of practical use when transistor-based counters became reliable and affordable. Today, Decatrons are used by electronic hobbyists in simple spinners that run off the mains frequency or as a numeric indicator for homemade clocks.